Okay, so in this lecture we will discuss with the topic how do metals and non-metals react. As you have seen that in the previous videos I have discussed about the all the activities given in the NCERT. Now we will be learning about the reason or the formation of bonds between metals and non-metals, how they react and what is the reason that they are reacting. So for that I am just giving you the concept that what happens when metals react with non-metals. So whenever the metals are there, they are actually doing this to complete their octet. So we can see that metals and non-metals then we can see that to complete their octet they are reacting with each other. Now if we check for the metals, generally metals in their outermost shell are having they are having electrons, that is either 1, 2 or 3. That means you can see these are the valence electrons which they are having in their outermost shell. If you talk about non-metals, then they are having 4, 5, 6 and 7 valence electrons in the outermost shell. So if you can see that according to octet theory, what it is required, then that these metals or non-metals should have total 8 electrons in their outermost shell, then they will be stable. So for stability the metals and non-metals react. Why? Because for stability according to octet theory they must have 8 electrons in their outermost shell. So to complete this 8 electrons, metals lose its electron and non-metals gain these electrons from the metals. So in this way the metals and non-metals used to react. Now let us see with the example, that is case of sodium. If you see the sodium, the outermost electronic configuration is 281, so the outermost electron is 1. And if you see chlorine, non-metal, that is chlorine, it is having 2, 8, 7, that is 7 electrons as a valence electron. Now all elements wants key their octet must be complete, so for that they used to fight with each other. Either some of them used to give up the electrons and some of them used to accept that electrons. It depends totally on the metals and non-metals. So generally metals used to lose the electron. Why? Because if you see that the variation is very much, that means sodium requires 7 electrons to complete its octet. That means this position must be fulfilled with this 8 electron. That means it requires how many electrons? 7 electrons it requires. And if you see the case of chlorine, it requires only 1 electron to complete the outermost shell. So what it will do? So if you see the shell of this sodium, 2, 1, 2, 3, 4, 5, 6, 7 and 8, and this extra shell which is having only single electron, this single electron needs 7 electron to complete the octet. So what it will do? The sodium is very smart. What it will do? It will just give up this electron, so that what will happen? This 8 electron will be sufficient for the sodium to become stable. So it will just remove this electron. So this shell will be now gone up, so this will be only stable by losing the electron. So it will lose the electron to get stable. Now if you talk about chlorine, what happens in case of chlorine? If you again draw the structure of atom, 2 1 2 3 4 5 6 7 and 8. Now if you see for this K L M, in M shell 1 2 3 4 5 6 7. Now one electron if it gets here, then it will be stable. So what chlorine will do? It only requires one electron. So this electron given up by the sodium will be accepted by this chlorine. So this electron lost electron, so it will gain electron. So it will gain electron. This electron will come here. Now it will become stable. So in this way, the metals and non-metals react. For what? For stability. To complete the octet, it requires 8 electron. So sodium lose 1 electron to get stable, and chlorine accept that electron to get stable. So this is the basis for the reaction of metals and non-metals. Now let us talk about the formation of these bond, or let us talk about the bond formed between sodium and chlorine, that is metals and non-metals. Okay, so the formation of bond takes place how? If you see the reaction for sodium, then sodium is actually for gaining the stability, it will lose the electron. So sodium plus electron, so basically it has lost the electron to become stable. Now it was 281 at this stage, now it becomes 28. So it is stable with 8 electrons. If you see the case of chlorine, then chlorine was 287. Now this electron will, if it gains, then it will become stable by obtaining the electronic configuration equal to noble gas 288. So this is the electronic configuration of noble gases. So what is basically happening here? This sodium is actually losing the electron, so it is gaining the positive sign here, and because chlorine is getting the electron, so it is acquiring the negative charge. So basically we can see that there is a exchange of electron or transfer of electron. We can see here the transfer of electron is taking place. So whenever there is a transfer of electron, then there is a formation of ionic bond. Which bond? Whenever there is a transfer of electron, there is a formation of ionic bond. So we can see that this NaCl is actually formed by transfer of electron. Then there is a ionic bond. Then this must be a ionic compound. Why? Because of the formation of ions, it is ionic compound, or one more word is there for this, that is electrovalent compound. Because of the transfer of electrons, the other name is electrovalent compound. So I hope this is very helpful for you, that to know that why the metals and non-metals react and forms ionic bond. Because of to complete their octets, metals need lose one electron and chlorine gains one electron, and in this way there is a transfer of electron from sodium to chlorine, and this transfer of electron is responsible for the formation of ionic bond, and due to this ionic bond between sodium and chlorine, this compound is a ionic compound or electrovalent compound. Now let us practice some of the examples. and sometimes the questions is asked for the electron dot structures, so we'll just practice that. If you talk about MgCl2, so we will say formation of MgCl2. It is also a ionic compound, so formation of MgCl2. How it is happening, or how this metals is reacting with this non-metals? For this, magnesium will lose electron. How much electrons it will lose? 2, because it is having an electronic configuration 282, so definitely it want to have a stability, so it will lose 2 electrons. Now if you see chlorine is 287, as we have seen in the case for the NaCl, so it will actually gain 1 electron. One chlorine will gain 1 electron, not 2 electrons. So you will write chlorine minus, and what is the state? It is 288. Now it becomes stable. Now what about the remaining 2 electron? The other chlorine will again get this leftover electron and it will acquire that electron. So that is why you are getting Cl2. That means 2 Cls is involved in with 1 Mg. Now if you draw the electron dot structure, now how the electron dot structure is formed, let us see. If you see the case of Mg, how many electrons it is losing? 2. So we will write 2 electrons here. What about chlorine? We will just write chlorine and we will mention the electrons. And we can say that electron dot structure, the last electrons we are writing here. Okay, so these are the valence electron which we are mentioning in the electron dot structure. Now if in case of chlorine, how many electrons are there? Valence electrons 7. So we'll mention 1, 2, 3, 4, 5, 6 and one more 7. So again 2 chlorines are in there, so we'll write 2 chlorine. Okay, now what will happen? This 1 electron will be placed here and other one will be placed here. So in this way you can see that this Mg will acquire 2 positive charge and this Cl will gain the electrons. So we will be just writing in this way, and because 2 chlorine are there, so we will be mentioning here 2 and 1 minus charge. So automatically that will be 2 minus because of the presence of 2 chlorine. So in this way you can draw the electron dot structure of any ionic compound or any covalent compound also we will learn. Okay. Now let us check out for the formation of calcium oxide. Formation of calcium oxide. Calcium is metal, oxygen is non-metal. How it is forming? Calcium is having, it is 2, 8, 8, 2, and if you see, then this 2 electron will be the valence electron. So calcium will actually lose 2 electrons. What about oxygen? Oxygen is 8, so it is O, that is electronic configuration 2, 6. So it requires 2 electrons to get stability. So it will only take the 2 electrons because it requires 2 electrons to get 8 electrons, that is stability. So now this oxygen will having O2 negative, and what is the state? 2, 8. So in this way this oxygen will be gaining these 2 electrons. Now how the electron dot structure will be formed? if you see calcium 2, so we'll write 2 electrons. What about oxygen? 6, so we'll write 6 electron. 1 2 3 4 5 6. Now there is a place for 2 electrons, so what will happen? 1 electron will be here and 1 will be here. So in this way this calcium will acquire 2 positive charge and this oxygen will acquire 2 minus charge with electrons. This way we will arrange it. So this is the electron dot structure for calcium oxides. So in this way you can practice all the other remaining ionic compounds electron dot structures. Now in my next video we will be learning about the properties of ionic compounds and related questions. Thank you. Keep watching. Bye bye.